All right, so section 3.6, day 3, right, for us here, even more curve sketching. So hopefully today's isn't too bad. We are going to have to factor something, and it may be something that you're not used to doing, but we are going to have to factor something. So when we do it, hopefully you guys are okay with it. You won't have too many of these types of problems. So when I do the factoring, don't worry so much about how I got to it. I'm gonna try not to give you any of these types of problems that require this type of factoring to occur. Okay, but we're gonna do example number 3. Why is this thing not writing? Oh, I know why. Never mind. So we're going to analyze f of x equal to, let's do a 4x cubed minus 2x squared. And that's going to be our function. All right, so 4x cubed minus 2x squared. So this one I'm making it a little bit easier for us. Okay? So remember, when we do this stuff, what we want to try to figure out is what is my x-intercept, y-intercept, my asymptotes, if there are any, and things like that. Okay? So first off, I'm going to have to take a derivative of this stuff at some point, but I got to find my x and y intercepts, right? So let me write this down. X intercept, y intercept, horizontal asymptote, vertical asymptote. And I'm just going to kind of put a box around those because that's what I got to do right now. So let me just kind of keep that on the side. Now, to find my x and y intercept, okay, remember the x-intercept, I have to set y equal to 0, right? So since this is not a fraction, then I don't set the numerator equal to 0, but I do set the function equal to 0. So 4x cubed minus 2x squared, I set that equal to 0 because y has to be 0 and you got to solve for it. So I'm going to factor out a 2x squared, and always factor, guys, okay? Don't try solving it the way it is. You factor as much as you can. So this would be an x minus 1 equals 0. So according to the zero product property from Algebra 1, we get 2x squared equals 0. X minus 1 equal to 0. The easy one to solve here, actually both of them are not too bad, but you're going to, let's start with the left side. You'll divide both sides by 2, so you get x squared equals 0, right, because I don't know what I did there. X squared equals 0, or x equal to plus or minus 0, but that's just a 0. On the other side, you add 1, so you get x equal to 1. So notice my x-intercepts. Did I mess up?
Yeah.
Where did I mess up?
When you factored out.
When I factored out?
2x squared times 2x.
Oh, yes, 2x minus 1. Thank you. So that would be x equal to half. Thank you for that. So, so fix that. It should be a 2x minus 1 inside of the parenthesis. Thank you very much. So we get 0, 0, and half 0. Okay? So we do get those two things. Now for my y-intercept, I let x equal to 0. Right? So for the y-intercept, you let x equal to 0. So in other words, you find f of 0. So it's 4 times 0 cubed minus 2 times 0 squared. That's 0. So it's 0, 0. If you guys remember, I told you that if it passes through the origin, that's usually both your x and y intercepts. So you can see right there, there's more proof of that. Now for your horizontal asymptote, remember you take your limit. So I'm just going to write limit as x approaches infinity of, that would be a 4x cubed minus 2x, wait, was that right? 4x cubed minus 2x squared, yes. So if I take the limit of that, there's nothing I can really do. I mean, I can't factor it to really help me do anything. You just kind of plug in the infinity, okay? So with this one right here, you're going to notice that it's going to basically be undefined, right? This is going to become infinite. It's going to be undefined. So there is no asymptote. There's none. Okay, because 4x cubed is going to go to infinity real fast compared to x squared. So it's going to be undefined for us. Okay, and then your vertical asymptote. Well, remember, for your vertical asymptote, you're supposed to set your denominator equal to 0, but I don't have a denominator. So there's none. All right, so there you go. We have that function defined for us. Okay. So far we have those pieces. Now we have to take our derivatives, right? So let's find my f of x function was 4x cubed minus 2x squared. So let's find our derivatives, okay? So f prime of x. Well, that's 12x squared minus 4x. Again, this is an easier problem. Like I said, I've given you two tough ones the previous 2 days, so we'll kind of do an easier one in case you see stuff like this, which you will. You'll see some that are easier to do. So we took our derivative. We got 12x squared minus 4x. We have to set that equal to 0 to find our critical numbers. So 12x squared minus 4x equals 0. I'm going to factor out a 4x. So that's going to be 3x minus 1 equals 0. And I'll set 4x equal to 0. 3x minus 1 equal to 0. So x is equal to 0, or x will be 1/3. So I'll write that down right now as a critical number. But let me do the second derivative first. So f double prime of x. So I know f prime of x is 12x squared minus 4x. So f double prime of x will be 24x minus 4. Right? We're getting that from this. Right? First derivative was 12x squared minus 4x. If I take a derivative of that, I get 24x minus 4. So now I got to set that equal to 0. And if I factor out a 4, I get a 6x minus 1 equal to 0. So I took out a 4. I got 6x minus 1 equals 0. So either 4 equals 0, which is not possible, or 6x minus 1 equals 0, which means that x would have to be 1/6. I'm not a big fan of the answers we're getting, all these fractions, but so be it. So let's see. Critical numbers. My critical numbers are x equals 0 and a 1/3, okay? Those are two numbers that I have to remember. So critical numbers for my first derivative. And then I have a number I have to check for my second derivative. Remember, I can't say that 1/6 is a point of inflection yet, right? Right now it's just kind of like a point of interest for me. So this would be my critical numbers for my second derivative, okay? So I'm just going to put like second derivative. That would just be x equal to 1/6. All right, so let me write my curve, sine graph here. So f prime of x, f double prime of x. Remember, I like to put these side by, not side by side, but one on top of the other because sometimes it'll help me see things. So my critical numbers are at 0 and 1/3. So 0, I'll say this is 1/3 right here. And then the other one is at 1/6. So it's halfway between 0 and 1/3. So now I got to start testing. Okay, I'm going to rewrite my first and second derivative here. F prime of x and f double prime of x. If I'm correct, this was 24x minus 4, which makes this 12x squared minus 4x. Is that right? Okay, so I got them right there. Those are my first and second derivatives. So what happens if I plug in a -1 into my first derivative? What do I get? So f prime of -1. What do I get for that? Positive or negative answer? Yeah, positive. So I'm going to put plus. What happens if I plug a number between 0 and 1/3? So let's say a 1/6. A 1/6. So f prime of 1/6. Well, let's see. A 1/6 squared, that'd be 12 over 1/6. That's 1 over 36. So 12 over 36 minus 4 over 6. If I reduce that, that'd be 1/3 minus 2/3. So that would be negative, right? That's a negative. What about if I plug in a number bigger than 1/3? So I'll try a 1. That's an easy number. F prime of 1. So it'd be 12 minus 4. All right, so I know this graph is going up, down, then up. Okay, so can I say that 0 is a relative maximum? Yeah, what do I call 1/3? That's a relative min, right? Now, does it change concavity? Well, we got to check that, right? So why don't I plug in a 0 for my second derivative? F double prime of 0. What do I get? Negative, right? This will be negative. So concave down. And then what about a 1 for my second derivative? That'd be a positive. So this is concave up. So I kind of know that my graph is going to look like this. It's going to go up and concave, like up to here, up to 0. It's going up, concave down. And then it's going to go concave down still up until it gets to 1/6. And then at 1/6, it's going to change concavity and still keep going down up to 1/3. And then it's going to start going up at that point. That's what I kind of see right now. Okay, so it rises up to 0, concave down. And then from 0 to 1/3, it goes down, but it's concave up. And then from 1/3 on, it goes up, and it's concave up. Okay, this is why I like to put those two sine graphs together, because it helps me kind of see what's going to happen. Now, to really solidify what I'm about to do, I'm going to have to graph this thing. And let's say I use, hopefully this fits. I don't know if it is, but we'll see. It may not, but we'll check. It was 3, right? 3 units. Okay. What was my critic? What was my x-intercept? It was 0, 0. I know that was 1. And what else? Half 0. So half 0. So right there. Okay. I didn't have any other y-intercepts, right? No horizontal asymptotes, no vertical asymptotes. Did I have some relative maxes and mins? Yeah, so where are they? So we know that one of them happened at 0. So let me write this down. F has a relative, let's go maximum of something at x equal to 0. Okay? What's the height of the function at x equal to 0? And again, I know it's a relative max because of this right here, okay? High point. So if I plug in a 0 into my original function, what do I get? 0. So that means this point right here, I'm going to circle it. That is actually a relative maximum. That's a high point, okay? So remember that. Remember that. Now, what's my low point? F has a relative minimum of something at x equal to 1/3. We found that out right there on the f prime of x sine graph. That was a relative minimum. So do me a favor, plug in the 1/3 into your function. And what do you get? You can give me a decimal, that's right, but we're going to plug in 1/3 into this. Okay, fx cubed minus 2x squared, okay? Let's see, f 1/3 is equal to 4 over 27 minus 2 over 9. 4 over 27 minus 2 over 9. What do you get? Either give me a decimal. That would probably help me more. What's 4 over 27 minus 2 over 9? Somebody got to have it. 4 over 27 minus 2 over 9. What is it? 0 point what? Negative, I think it should be. Negative what? Negative 2. Negative 2? Oh, negative 2 over 27. But what's 0.078? 4 after that. So we'll leave it. So 0.074. Okay. So let me put that right here. Negative 0.074. So it's going to be really, really close. Like right here. Not even right there. It might actually be really, really close over here, right? But I'm just going to sketch it. I'm just going to kind of put it approximately. So there you go. Okay. I know that my point of inflection is going to occur. What's 1 over 6? It almost doesn't seem right. Yeah, what's 1 over 6? What's that value? I'm just trying to think of this here. All right, so why is that? Why is that? My point of inflection should be there. So my actual minimum should be more to the right. Are you guys sure that's the answer for plugging in a 1/3? That's what it's giving you? Yeah, because it's supposed, notice how this sine graph, your minimum occurs here, okay? But the point of inflection is to the left of it. So it just doesn't seem to make sense at the 1/3. Because your point of inflection should occur at 1/6, which should be right about here, like this line right about there. That's halfway, right? So, I'm not sure about that. Hold on. Well, we're just gonna kind of go with it, but I don't know. The numbers don't seem to make a lot of sense for me right now. Maybe I can try to look at it after. But yeah, so we'll just put a point right here, like I said, for the other one. Now, once we have that, we know that this graph is supposed to go up. Okay, if you look at your sine graph, up to 0, concave down, and then down all the way up to 1/3. So that's that purple point. Down, concave down. That's kind of small. Okay, let me show you there. And then it's supposed to change direction at that point of inflection and go up. Okay, so if you look at the highlighted graph that I put, that's kind of the way it's supposed to look. And again, you're just doing a sketch. This doesn't mean that it has to be perfect, but you want to try to put as many points on there that make sense. Okay, I was only able to get 3 of them on there that made sense. They do check out. Okay, maybe it's just maybe in my head I'm miscalculating something. So that's good. That's good. But yeah, that's the function that we're looking at. Okay. So hopefully that one. I mean, I know I was kind of, without a calculator, I'm trying to do some of this stuff in my head and I'm trying to see if it works out, but I could be miscalculating something. But do you guys understand how that one works? It's supposed to be a little bit easier than the other ones. Not sure if you feel the same. Maybe you're like, no, I like the other ones better. But yeah, we're basically just plugging in the information near the end just to figure out how high should I go, how low should I go, etc. But other than that, it should basically kind of look like that. Oh, by the way, I think I forgot to put 1 point in there. I forgot to put your minimum, so it would be like right here. That would be your minimum. Let me see if I could do this. And right here, there would be a little point for your point of inflection. So kind of like that. Okay. So I'll give you guys the homework that's supposed to be assigned. Tomorrow you guys are just going to have a book day to work on this. Okay? I really suggest you guys work on this thing in class because you might have a lot of questions. We'll see.